All right, today, lesson 10C, triangles, sides, and angles. Part of the very beginning of this lesson should be some things that you hopefully recall from 6th grade, and then we'll kind of move together from there. So our focus today is on finding missing angles in a triangle, and by comparing also sides and angles of a triangle, and then of course classifying them. So let's go ahead and get started. From 6th grade, you should have done a little bit of work by naming triangle by their angles. So for example, a triangle like this is acute because all the angles are less than 90 degrees. Does that sound familiar to you? All right, if it has a right angle inside the triangle, that's called a right triangle. And then if we have one obtuse angle in a triangle, that is an obtuse triangle. And then we can also name it by its sides. If all the sides are the same, or they have equal length, that's an equilateral triangle. If two of the three sides are equal in length, that is an isosceles triangle. And then if all three sides have different length, that is a scalene triangle. So sometimes we're asked to name a triangle by its angles and its sides. So that's our first focus right now. Let's do number 1 together, and then I'll have you try the other 3. Could somebody raise your hand and tell me how we would first of all name this triangle by its angles? Yeah.
It would be an isosceles because both of the sides are 6. And only two
Well, but
equal.
that's 6. The 2 6s and the 10, those are the sides. Did you say it was isosceles? Okay, I'm sorry, I misunderstood you. All right, so you're right. It has 2 equal sides there, 2 sides of equal length, so it's isosceles. So that's by its sides, but we also need to deal with it by its angles. Yes?
It's acute
What makes you think it's acute?
because all the angles are less than 90 degrees.
Okay, that angle right there, you're right. This angle right here, you are correct. Look at this angle right here. Is that an acute angle? Look how big the opening is. So that makes this not an acute angle.
I think that this is a isosceles and an obtuse.
Yes, it's obtuse and isosceles. We're supposed to name it by its angles and its sides. So by its angles, and I just pointed out the fact that there's one obtuse angle in there, so it's obtuse, and by its sides, it's isosceles. So that's what we're doing in 2, 3, and 4, naming it by its angles and naming it by its sides. Go ahead and do number 2, 3, and 4, please. Number 2, first of all, by its angles, you can see all 3 angles are clearly acute. So it's an acute triangle, and then by its sides, those little tick marks that you see right there tell us that all 3 sides are the same. So this is acute equilateral, an acute equilateral triangle. When it states to name it by its angles and its sides, you need to have both, by its angles and its sides. Number 3, you can see by the little square in the corner that this is a right triangle, and then by its sides, all 3 of those side lengths are different. Therefore, this is right scalene. And then number 4, we can see by its angles, 2 of them are acute, but much like in number 1, look at this angle right here. And if you have trouble seeing it, turn your paper around, and it should be clear to you. That is an obtuse angle right there. If I take that off and draw it again, we have an angle right here that is clearly bigger than 90 degrees. Clearly bigger than 90. So this is an obtuse scalene triangle. Let's go to the next 4, and I'd like you to do all 4 of those. Same idea, but this time I'm going to have you shoulder partner once you finish them. So go ahead and do 5, 6, 7, and 8. I'll give you about a minute to a minute and a half, and then we'll compare with our shoulder partner. Number 5, by its angles, it is acute. Some of you may think that that's a right triangle, but typically, unless there's a square in the corner, it's not a right triangle. So this is an acute scalene triangle. Number 6, which is right below that, the 2 little symbols in the angles at the bottom, which those are called base angles. That means those 2 angles are the same. And the 2 sides are also the same that are opposite those. But if you look at the angles, it's acute. The sides makes it isosceles. Number 7, the little square in the corner there, means we have a right triangle and all the sides are different. So that makes it scalene, right scalene. And number 8 is right isosceles. Any questions about that concept? So sometimes we're asked one or both of those questions as far as by its angles and sides with a picture, and sometimes without a picture. So in the next 3 problems, you're supposed to tell whether the triangle is scalene, isosceles, or equilateral. So right at this point, for these 3, we're only naming by their sides, giving the 3 measurements. So go ahead and try 1, 2, and 3. State whether it's scalene, isosceles, or equilateral. You're only asked to name them by the sides. All 3 sides have different lengths, therefore this is scalene. What you'll find out next year is that not only is that scalene, but it also ends up being a right triangle using the converse of the Pythagorean theorem. Number 2, this is isosceles because of the fact that we have 2 sides that have equal length. And then number 3, all 3 sides have equal length, therefore it is equilateral. All right, so let's return to the idea of talking about triangles and the angles inside of them. And I don't know, you may have talked about this last year, but even if you didn't, it's an easy concept. Our goal as of 2 lessons ago was to be able to find missing angles without a protractor. We can do that within any triangle if we know 2 of the 3 angles, and that's because there's a rule with respect to the angles inside of a triangle, and sometimes it's referred to as the 180 rule or the triangle sum theorem. And the triangle sum theorem says this, that every triangle, and this is where you have to fill in something, every triangle has angles whose sum equals 180 degrees. And like I said, I don't know whether you talked about that last year or not. You may or may not, but even if you didn't, it's an easy concept. Okay? Every triangle has angles whose sum equals 180 degrees. So that means if you add up all 3 angles inside of any triangle, they add up to 180 degrees. For example, everybody find angle X, please. This is not number 1. This is the one that's right off to the side of whether you had to fill in a blank spot. All right, so let me make it clear, and I've been walking around looking to see how some of you are doing this problem. Some of you are just adding the 85 and 60 and taking it away from 180, and that's fine sometimes, but what would you do if this x was something else? Like what if it was 5x plus 1? Well, then what you just did won't work. Not if we're trying to solve for x. So we really should be taking a look at this the same way we did some of those problems that we did last week. In other words, we should use an equation because that's what the standard is anyway. So here's what I'm saying. We have angle x plus an 85 degree angle plus a 60 degree angle. Now if you didn't do it this way, I would like you to write this down. All 3 of those are supposed to be equal to or have a sum of 180 degrees. And the reason is simple. If you go and look at starting at number 3, you're going to see that those problems look exactly like what I was just referring to. So we should just start with the easy one, setting them up this way. So from there, you would combine both of your like terms together, the 2 constants, 85 and 60 is 145, and then from there, subtract 145 from both sides. And I'm kind of running out of room here, but it should be clear to you that x is 35.
Do you put the degrees?
In this case, we could because that's actually what the angle is. We're just finding angle x, and x is 35 degrees. So in this case, we could. All right. I would like everybody to try the, and notice how I am saying we need to use an equation. I would like everybody now to go ahead and do number 1 and number 2. All right, before we go through number 1 and number 2, I want to show you a little demo here to prove to you that all 3 angles inside any triangle will always add up to 180. So what we're going to have here is we're going to have a triangle, and this is a proof that it truly is 180 degrees. Now before I even do that, what's a straight line? 180 degrees, right? All right, so watch. I'm going to move that one down there and move this one, as you can see, all the way over to there. And what we have here is we have a straight line, and we knew from before that angles on a straight line, like in this situation right here, they add up to 180 degrees. So that means this angle and this angle and this angle. So that's proof that three angles in a triangle do really add up to 180 degrees. All right, I need to, forgot to click off of that, but I'll get back to here right now. Okay, and just like last week, I stated why we have to use an equation. The reason is because it's clear in the standard itself that we are supposed to use equations to solve these things. All right, so number one, the equation would look like this. X plus 100 plus 35 is equal to 180 because, once again, that angle plus that angle plus that angle is supposed to add up to 180 degrees. Combine your constants together, subtract 135 from both sides, and you can see that x is 45. And number two, same idea. Y plus 18 plus 24 is equal to 180. Combine your constants together, those are the like terms, and subtract 42, and we get y equals 138. Those are easy simply because we only have x or y as far as the missing angle goes. But what about a problem like number 3? I would like everybody to try number 3. In a lot of respects, this is not much different than the kinds of things that we were doing last week. But let's see how it goes. So we know that the sum of any three triangles, or any three angles in a triangle, have a sum of 180. One of the angles is x plus 5, one of them is 100, and one of them is 35. So when I set up my equation, it looks like this. Now you should combine your constants, your 5, your 100, and your 35 together. That gives us this. Then we subtract 140 from each side, and we get x equals 40. X is equal to 40. X is not equal to 40 degrees. But if you were then asked to find the angle, here's what you could do. You could take that 40 and substitute it in right there. So what is the angle? No, it's not x equals. What is the angle? How big is that angle right there? It's what? It's not 40 degrees. It's 45 degrees. The angle is 45 degrees, but x equals 40. We clearly just showed that x equals 40, and if I substitute it in right there, 40 plus 5 is 45. So the angle is 45 degrees, but x is equal to 40. Now I want you to do the same sort of thing for number 4. Three angles in any triangle will always have a sum of 180 degrees. That means y minus 8 plus 18 plus 24. Those are those three angles that are there. That is supposed to be equal to 180. From there, you should combine your constants together. Negative 8 plus 18 is 10. 10 plus 24 is 34. So we have something like this. And then subtract 34 from both sides. Y is equal to 146. We have to do that part first, but that's not what the angle is. What is the angle? What is it? 130 what? 138. It is 138 because 146, when you substitute it in right there, which is what I'm showing right here, minus 8 is 138 degrees. So the measure of that angle is 138 degrees. All right, let's go to the next page in the notes. And this is the last idea for today. And this is where we compare sides and angles. So our goal has been to find missing angles without a protractor. Our goal is also to find out information about angles and sides together without a protractor or a ruler. So if we have something that looks like this, we can clearly see that this is an obtuse triangle simply because we have one obtuse angle in there. but without a ruler, which side is the shortest? I want you to take a look at that, and the picture of this is in your notes. Quickly turn to your shoulder partner and point out which side. Oh, hold on, I'm going to take it up a notch. Clearly point out which side you think is the shortest, and then the flip of that, point out which side you think is the longest. You got about 30 seconds. Go.
One that's the shortest is on the left side.
What is observing appropriate classroom behavior?
Oh, okay. All right, back up front, please. All right, so I was kind of watching where people were pointing. The side that is the shortest is this side right here. Okay? Now, how do we know that? Well, there's a mathematical reason for that. And in addition to that, it's obvious which side is the longest. That's right here. Okay, but why is that happening? Well, the idea of opposite and adjacent, which is what I'm about to talk about. We already talked about adjacent. These are used a lot in math in high school, a branch of mathematics called trigonometry. Opposite, adjacent, hypotenuse, things like that. Used a lot in trigonometry where you're trying to find missing pieces to specific types of triangles. But the thing that we're going to talk about is this. 35 degrees is the smallest angle in that triangle. Do we agree with that?
Yes.
All right. The side that's opposite that is going to have to be the shortest side. So that side over there is the side opposite that angle, and it is the shortest side. And some of you should be probably adding these types of things to your notes. Now, I also asked you to find the longest side. Well, as it turns out, since 100 degrees is the largest angle, the side opposite that has to be the longest side. And that's basically what we're going to be talking about the rest of this lesson, is trying to find, not necessarily by the picture itself, but by looking at sides that are opposite angles or angles that are opposite sides. All right. I'm going to skip that demo just for time purposes. So here's what you're supposed to do here. You're supposed to find the shortest and the longest side. Now, is there something you're going to have to do before you can really be certain of that in this problem? What's that?
Make an equation.
Make an equation. Well, why? What?
I don't agree with it. You're supposed to find the missing angle.
Yeah, you got to find the missing angle first, and that's really what he was trying to say. So you need to find that angle x, which is why we just learned before this the triangle sum theorem. So everybody quickly find angle x. Then you can really, truly find the shortest and the longest side. So go ahead and try that. So we need to find the missing angle first. The missing angle, much like the previous problems, this one is 46 degrees. So now that we know that that missing angle is 46 degrees, we can clearly see that side A is the shortest side because it's opposite the smallest angle. And we should be able to clearly see that side C is the longest side because it is opposite the biggest angle. All right, go ahead and try the next problem, which is to the right of that in your notes. Find the shortest and longest sides. Now, one of the things I accidentally skipped on the last one was this. Let me go. I'm just going backwards for a second here. So we were naming them by A, B, or C, but what if, and I want everybody to look up here, what if I took away the A, B, C and instead labeled the vertexes like this? So since we already knew that this side right here is the shortest side, that side is side line segment BC. And that goes back to 2 or 3 days ago. And we also know that this side over here is the longest side. So if we had corners or vertices at given in the problem like this one, ABC. BA or AB, line segment BA or line segment AB, that would be the longest side in there. So sometimes you may not be given sides like I gave you in the previous one. You may have the corners may have letters there. In other words, you may have vertices there. And so if that's the case, you need to label it like that. I accidentally skipped right past that. All right, so in this one, we need to find the missing angle. And that happens to be 31 degrees. I went around looking for that, and I did see that on every paper for the most part. And then from there, obviously, side B is the smallest side, and side A is the longest side. And then let's now do the flip of this. If the shortest side is opposite the smallest angle, and the longest side is opposite the biggest angle, well, that would also mean that the biggest angle is opposite the longest side. That should make sense to you. The smallest angle is opposite the shortest side. So there's the shortest side, so that means that that has to be the smallest angle, and I know there's a couple of areas where you need to fill something in your notes right now. And then this is the longest side, so the angle opposite that has to be the largest angle. And that should kind of make sense to you. So we have one more problem, and that is a picture where you are asked to find the smallest and the longest angle. Now before you do that, hold on a second. What if I put P, Q, R right here? Could somebody please name the largest angle correctly? Leo, angle what? Angle what? Well, we don't name angles by two letters. What is the largest angle? Angle what? Angle R, or with three letters, it would be P, R, Q. We did this naming of angles. We did this naming of angles last week. There's PRQ. That's angle PRQ. That is the largest angle. And I'm telling you that because that's the way we need to do it for this very last problem here. So everybody please find the smallest and the largest angles and make sure that you name them with three letters. All right, so smallest angle is opposite the shortest side. And that would be angle ACB or angle BCA. And if we named it by one, it would be angle C. Largest angle is opposite the largest side or the longest side. There's the longest side. The angle opposite that right there is angle B or angle ABC or angle CBA. All right, any questions about that? Yes?
On the homework, can you put like the small letters or the
I would prefer you put three letter because obviously some of us need a little practice with that. Okay? All right, we are finished for today.